We can also symbolize a negative universal as a compound statement, again by instantiating it, applying it to an arbitrary thing. So an example of a negative universal statement is, no fish can fly. What are the two categories in play here? Well, fish and flying things. So we could have the statement, this thing is a fish, right? Applying that fish category to an arbitrary thing. And we can have, this thing can fly. We'll call these P and Q. And again, let's look at a truth table and see how the truth values of P and Q correspond to the truth values of no fish can fly. If P is true and Q is true, then we're looking at something. P is true, this thing is a fish. Q is true, this thing can fly. So this thing is a fish that can fly. Can no fish can fly be true then? Well, no, because here, behold, I've found a fish that can fly. So that means that no fish can fly is not true. In fact, no fish can fly is false. What if P is true while Q is false? Well, P is true, this thing is a fish. Q is false, this thing cannot fly. So if P is true and Q is false, this thing is a fish that can't fly. Well, no fish can fly seems to suggest that we have lots of fish that can't fly, right? No fish can fly, that's no problem if we have a fish that can't fly. If P is false and Q is true, that means that we have something, P is false, it's not a fish. Q is true, it can fly. Again, that's no problem. If no fish can fly, if there are any flying things, then they're not fish. So if this thing is not a fish, but can fly, again, we have no problem with no fish can fly. That can still be true. And then if P is false and Q is also false, well, P is false, so this is not a fish. Q is false, so this can't fly. This is not a fish and can't fly. That doesn't present a problem for no fish can fly, right? Saying that no fish can fly doesn't mean that everything that's not a fish can fly. There are lots of things that can't fly that aren't fish. So that's no problem. Okay, so we get the column false, true, true, true. But this gives us a problem. This doesn't match any of our standard columns. What can we do? Well, we saw before that when we're making truth tables, we can bring in some nots, and that kind of changes around where the trues and falses land. So let's try this. Our truth table is true in 3 rows and false in 1 row. We have 2 different connectors that are true in 3 rows and false in 1 row. It could be something that we get using an OR, that's that wedge shape pointed downward, or an if-then, that's the arrow. Now the OR is easier to work with, so let's try this using an OR. We're just going to make a truth table showing P and Q, all the possible negations of those, and then every possible OR combination. P or Q, not P or Q, P or not Q, not P or not Q. So first to symbolize not P, that's just the opposite truth value of P. P is true, not P is false. P is true, not P is false. P is false, not P is true, P is false, not P is true. To symbolize not Q, same process. Q is true, not Q is false. Q is false, not Q is true. Q is true, not Q is false. Q is false, not Q is true. Okay, and remember, or is true if at least one of the statements is true. It's false if they're both false. So P or Q, P is true, Q is true, P or Q is true. P is true, Q is false, P or Q is true. P is false, but Q is true, P or Q is true. P is false, Q is also false, P or Q is false. Not P or Q, we'll want to look at the not P column and the Q column. Not P is false, but Q is true. Not P or Q is true. Not P is false, Q is also false. Not P or Q, that's when it's false. Not P is true, Q is also true. The or is true. Not P is true, Q is false. The or is true. For P or not Q, we want to look at the P column and the not Q column. So P is true, not Q is false, the or is true, right? At least one of them is true. P is true, not Q is true, the or is true. P is false, Q is false. When they're both false, that's when the or is false. And then P is false, not Q is true, the or is true. Okay. And then all that's left is not P or not Q. For that one, we'll look at the not P column and the not Q column. Not P is false, not Q is false. Oh, well, that's when the or is false. Not P is false, but not Q is true. One of them's true, so the or is true. Not P is true, not Q is false. One of them's true, so the or is true. P is true, Q is also true. The or is true as long as anything is true. Okay, so notice, by doing this, we got one column for each possible location of the false. We can get the false column to be wherever we want by playing around with the negatives. We can get the false row to be wherever we want by playing around with the negations. In this case, we want the false row to be the first row, and that's this column. So we will symbolize no fish can fly as not P or not Q, meaning a thing either isn't a fish or can't fly. Now, you may have noticed that we made a choice there. We made a choice to use a disjunction, an or statement, rather than an if-then statement. Could we have symbolized this using an if-then statement? Yes, we could have. However, because the or statement is easier to work with, we're going to prefer to symbolize a negative universal in this way, not P or not Q.